Welcome to the world of industrial-scale logging like you've never seen before. In this video, we take you deep into the forests where giants roam. Machines, not animals. These aren't your average chainsaws or tractors. These are multi-ton beasts that dominate the timber industry. From North America's vast pine forests to rugged terrain in Australia and Canada, these machines shape the future of forestry. You're about to witness the raw power and precision of the most massive, advanced logging equipment in the world. Massive feller bunchers grip and slice through 100-foot trees like twigs. Tracked harvesters equipped with robotic arms strip trees down in seconds. Forwarders haul tons of logs across rough ground with GPS precision. Stump grinders the size of SUVs pulverize roots with hydraulic torque. Giant wheeled skidders pull entire tree lines like it's nothing. Self-leveling processors adjust to steep slopes and maintain stability under any load. Double-blade saw heads spin faster than the eye can track, slicing hardwood in milliseconds. Some of these machines are over 40 feet long and cost more than $1 million each. Each machine is designed for power, efficiency, and minimal environmental impact. Operators sit in climate-controlled cabins with touchscreens and 360-degree cameras. Trees are mapped with drones and GPS before any machine even touches the ground. Automated harvesters follow digital plans to cut with maximum efficiency. Logs are processed and measured instantly inside the machine. No manual cutting needed. AI software helps plan log lengths and angles for transportation and sale. The entire logging site is monitored by satellite and cloud-based systems. Safety protocols are enhanced with real-time machine feedback and obstacle detection. One operator can manage an entire zone with multiple machines working in sync. Even in snow or extreme heat, these machines operate with minimal downtime. Forests are managed sustainably, with replanting programs and selective harvesting. Every log harvested is tagged, tracked, and certified for eco-compliance. These machines feature hybrid electric engines for reduced emissions and longer fuel cycles. Touchscreen dashboards allow real-time adjustments to blade speed and angle. Some harvesters use LiDAR and AI to identify tree species and growth direction. Maintenance schedules are automated with predictive diagnostics. Many of these machines are built in the USA, Sweden, Germany, and Finland, engineering at its finest. Laser-guided saws ensure precision to the centimeter, reducing waste. With the push of a button, a tree is cut, stripped, measured, and stacked. Advanced track systems allow these machines to float over wetlands and minimize soil damage. Operators often receive VR-based training before ever stepping into the cab. The cab interiors are designed more like airplane cockpits than tractors. The largest tree ever harvested by a single machine weighed over 25 tons. Some saw blades spin at over 3,000 RPM and can cut through 3-foot trunks in under 5 seconds. Each tracked harvester uses more than 3,000 parts and takes months to assemble. Most logging operators consider these machines their second home. Some even customize the interiors. Logging in steep terrain requires machines with automatic balancing systems. Thermal imaging is used in cold climates to monitor hydraulic systems. Each tire on a large skidder can cost over $10,000 to replace. Modern harvesters are quieter and cleaner than machines from even a decade ago. Forestry equipment plays a critical role in wildfire prevention and controlled thinning. Watching these machines work is like seeing industrial ballet, controlled, massive, efficient. Drone footage reveals just how massive these machines are from above. Logging trailers extend over 70 feet and carry massive loads across mountain roads. In the control cabin, operators use joystick systems and multi-display monitors. Every movement is tracked, logged, and stored for reporting and optimization. AI-driven systems reduce operator fatigue and increase safety. Real-time satellite maps show the live location of every unit in the field. The chainsaws used in harvesters are cooled with automated oil injection systems. Some machines are amphibious and operate in marshes and swamps with ease. Remote diagnostics teams monitor operations from hundreds of miles away. Logging has evolved from an axe and saw to autonomous industrial robotics. The hydraulic systems in modern machines can generate over 10,000 psi of pressure. Cab glass is reinforced to withstand flying debris, falling limbs, and impacts. Seat suspension systems adjust to terrain bumps and operator posture in real time. Each forwarder can carry up to 18 tons of timber per run. Tree feller heads clamp, cut, rotate, and stack in under 15 seconds. Skidder winches use synthetic cables with brake strengths over 60,000 pounds. Chainsaw bars on heavy harvesters are often over 3 feet long. These machines can cut and process up to 800 trees per day. Precision is key. Waste is reduced by matching log length to buyer specs automatically. Regan braking systems help recover energy when descending steep slopes. Modern logging yards include wireless communication hubs and smart dispatch systems. The fuel tanks on some machines hold over 250 gallons. Despite their size, many machines emit less CO2 than trucks from the 1990s. Rubber tracks reduce impact on forest floors and improve traction. Climate data and soil sensors guide where and when trees are harvested. The operator's seat is often heated, ventilated, and ergonomically adjustable. Headlights include infrared modes for night logging operations. Machines automatically shut down if they detect system irregularities or terrain danger. Some forwarders have 8 wheels for improved flotation and turning radius. Milling attachments can convert timber to planks on-site in certain models. Forestry robots are being developed to work in teams with human supervisors. The USA is one of the leading innovators in forest machinery technology. Sawmills rely on consistent, accurate cuts made directly in the field. Clear cutting is being replaced by smarter, selective harvesting. Logging apps now allow real-time machine updates via smartphone. Biomass from branches and offcuts is converted to pellets for fuel. Canadian provinces lead in certification programs for sustainable forestry. Logging operators often have backgrounds in both mechanics and data analysis. Forestry isn't just hard work, it's high-tech strategy today. This is the cutting edge of forestry, quite literally. Massive machines, intelligent design, nature and tech working in harmony. The future of logging isn't just big, it's smart, sustainable, and global. From the forests of Oregon to the boreal woods of Canada, these machines are shaping our future. Subscribe for more videos on heavy equipment, forestry innovation, and the world's most powerful machines. Every bolt, hose, and circuit board in these machines is engineered for forest survival. Hydraulic lines are protected with steel mesh armor to prevent rupture in rugged terrain. Air filtration systems keep out sawdust, pollen, and extreme weather. Diagnostic sensors run 24/7, checking oil pressure, temperature, and mechanical strain. Operators use high-definition monitors to track log counts, machine health, and GPS location. Real-time video feeds from drone scouts are sometimes used to plan optimal harvest routes. Machine maintenance crews carry laptops, not wrenches, to update firmware in the field. Many machines have satellite uplinks to communicate with forestry hubs across continents. Logging companies now employ software engineers alongside mechanics and loggers. Advanced forestry tech has become a billion-dollar industry in North America alone. In Finland, AI-enabled harvesters can read the curvature of tree trunks to calculate best cutting angles. Australia's outback loggers use solar-charged support vehicles for remote operations. In Canada, hybrid machines are being used for year-round logging with minimal emissions. Some U.S. forestry firms are integrating blockchain to verify legal, sustainable logging practices. The U.K. has launched pilot programs for autonomous logging in small-scale managed forests. Japan's precision forestry uses robotic loggers to work on steep, mountainous terrain. Global timber demand is driving innovation in harvesting, transportation, and processing. The construction, furniture, and paper industries depend on accurate, high-volume forest logistics. Eco-certifications like FSC and PEFC now rely on machine-generated traceability reports. Precision logging reduces waste, increases revenue, and improves land regeneration rates. Most modern harvesters are designed to last 10 to 15 years under extreme usage. After a major overhaul, some machines are refurbished and exported to other countries. The second-hand market for forestry machines is active across Europe and Latin America. High-end manufacturers like John Deere, Komatsu, Ponce, and Tigercat lead the global market. Training programs for operators now include drone piloting and GIS mapping. Logging machine simulators are used to practice on digital terrain before real deployment. Smart machine interfaces reduce human error and optimize cutting patterns. Log data is uploaded to cloud platforms accessible from HQ in real time. Multi-axle log trucks sync with machines via digital manifests to coordinate pickup. Even the tires on these machines include RFID sensors to monitor wear and balance. Logistics hubs track hundreds of machines across multiple forests using AI dispatch tools. Some machines switch to electric-only mode in protected or noise-sensitive areas. Biodegradable hydraulic fluids are used to prevent pollution from accidental spills. Sustainable logging practices now focus on low-impact routes and regenerative tree planting. Large-scale operations often include wildlife monitoring and soil health reports. Forestry teams may include ecologists, engineers, and climate analysts. Forest thinning helps prevent catastrophic wildfires and promotes healthier ecosystems. These machines play a role in carbon cycle regulation and biomass management. Even offcuts, bark, and chips are recycled into composite materials or fuel. Some harvesters now integrate biomass balers to collect waste in real time. Camera systems on machines can identify animals or humans and stop automatically. Safety lights and motion alarms are standard in newer machine generations. Touchless maintenance diagnostics can be run via tablet before a shift starts. Interior cabin cameras improve operator support and safety compliance. Voice-controlled UIs allow operators to change settings without removing hands from controls. Rain sensors auto-adjust tire pressure and engine tuning for slippery conditions. Frost detection prevents cold start damage in sub-zero environments. Log pile scanners measure timber with laser precision for invoicing accuracy. Each felled tree can be assigned a QR code for end-to-end tracking. Smart contracts now allow automatic payments per cubic meter harvested. The machines are not only strong, they are becoming intelligent. Future models may include swarming drones for replanting or monitoring. Machine learning allows equipment to adjust its method per terrain and forest type. Even saw blade wear is monitored in real time for replacement efficiency. Energy recovery systems, power lights, tools, and auxiliary devices on board. Telematics software helps forecast productivity across regions and crews. Eco-logging fleets are increasingly electric or hybrid, supported by mobile charging stations. In many countries, regulations now require real-time digital forest monitoring. Public access maps show where sustainable harvesting is taking place. Consumer-facing apps allow buyers to scan timber origin and harvest method. Heavy machinery is also influencing policy and legislation on land management. Digital forestry is a growing academic and professional field. Universities in the US and Europe now offer degrees focused on smart forestry systems. Machine-aided conservation is reshaping how we balance economy and ecology. While the machines are large, their environmental footprint is being minimized. Sensors collect rainfall, soil pH, and wind data alongside production metrics. Some machines even self-correct their alignment to follow terrain curvature. Forestry road building is optimized using 3D terrain modeling. Real-time climate forecasts help schedule harvests to avoid erosion and runoff. Digital twins of machines are created for testing new designs in virtual forests. Inside the cabins, comfort is everything. Adjustable seats, panoramic views, heated floors. Bluetooth audio systems allow operators to stay alert without distraction. Interior lights auto-dim at dusk to improve visibility and reduce glare. Noise cancellation systems protect hearing while enhancing situational awareness. The average operator shift runs 10 to 12 hours, often in extreme conditions. Operators often describe their machines as an extension of themselves. Respect for the forest is built into every design decision. The goal is not just efficiency, but harmony between nature and industry. Even the paint used on these machines is eco-friendly and weather-resistant. Machine data is used by policymakers, researchers, and environmental watchdogs. Logging is no longer a brute force task. It's intelligent, deliberate, and data-driven. Massive doesn't mean wasteful. Today's machines are smarter than ever. You're witnessing the future of forestry unfold in real time. The forests of tomorrow are being shaped by today's technology. Each machine represents thousands of hours in design, testing, and refinement. Behind every cut is a calculation, one that balances economy, ecology, and ethics. From Oregon to British Columbia, Finland to Queensland, the logging revolution is global. Heavy machinery is now part of digital transformation across industries. The next decade will bring even more automation, sustainability, and precision. If you think logging is just about chainsaws and axes, think again.